Hello everyone, this is Jabal Sonisha B. My register number is URK23CS1119. Today we are going to see about performance analysis on KNN classification technique. For this, we have questions. We have to develop an KNN classification model for the diabetes dataset using the scikit-learn library. So first we have to read the data. For reading the data, we have to import the library, and next I have read my data set. Then I'm printing first five values of the data set. The next thing is we have to clean the data. We have to replace zero uh, column with nan value, identify the column with null value, and filling the null values by imputing the mean values in the corresponding column. So we are going to clean the data. For that, we are giving the columns, and we are replacing the zero value into nan value. For that, I'm just using replace keyword with for the zeros column, the zeros value, we are just giving nan values, and we are printing the first five values. This is going to be the output for that. Then we are printing the null values in the data set. So for that, I'm just giving df.isNull dot sum of the total values of the columns are the data set is this. So the null values were this. For then, the city has zero null value, the pregnancies has zero, like that we have all the values. To clear all the null values, we are just giving a numeric value for each one. So for that, I'm just giving fill now with the mean values of the each column, and we are giving the then we are printing the values. So this is going to be our output. The next thing we are going to do is use the columns pregnancy, glucose, blood pressure, skin thickness, insulin, BMI, diabetes pedigree function, age as the independent variable. For that, we are giving the values of pregnancy, glucose, blood pressure, skin thickness, insulin uh, as the independent variables. For this, I'm just printing those values. And next, we are going to use the target values as outcome. No means non-diabetic patients, S means diabetic patients. So I'm just giving the outcome a 1, and I'm just going to print the value count for to find the non-diabetic and diabetic one. So no means no diabetic, S means they have diabetics. This is going to be our output. Our next thing to do is we have to encode the categorical value of the target column to the numerical value. For that, I'm just using scikit-learn library. We are importing the label encoder. Then we are calling that label encoder, and we are transforming the y values. And we are going to encode the target values where till 10 values. So the targeted encoder value is 1010101011. So this is our encoded value. The next thing we are going to do is we are going to divide the data into training 75% and testing the remaining 25%. For it, I'm just also importing the library. So we are importing test split off. We are splitting the datas x train x test. For x1 we are going to train and test. For y also we are going to train and test. For that, we are splitting x value, y value. The test size is going to be 0.25, and the random state is going to be 42. Then I'm going to print training size, which is x train dot shape, and testing size is going to be test dot shape. So this is going to be the output. The next thing we are going to do is we are going to perform the classification with the k value as 3. For that, I'm just importing the libraries, and for confirmation confusion matrices, uh, I'm just going to work with it. Here we are gonna do this two questions both. So analyze the performance of the classifier with various performance measures. We are gonna display the confusion matrix and accuracy, recall, precision, specificity, F-score, receiver operating characteristics, ROC curve, and area under curve score. So for that, I'm just giving the values. For confirmation value, we are going to give confirmation matrices X test and Y predict. Then we are printing. For accuracy, precision, and recall and F score, we are gonna give find the accuracy score in Y test and Y predict. So for precision score, we are gonna again we are testing test giving the predict value and the test value. Then we are finding the recall score, and then we are going with F1 score. Then for specificity, Tn is equal to Tn divided by Tn plus Fp. So we are gonna ravel, and that we are gonna find the specificity, and we are printing it. Next, ROC and AUC. We are going to predict the probability, and we are going to test. Then the threshold, ROC curve of Y test and Y predict. Then we are going to plot everything in a graph. We are going to use line plot, and we are just giving the output. So first confusion matrix is this one. The accuracy value is going to be 0.6615, precision value is 0.5263, then the recall value is and the sensitivity value is going to be 0.5797, the specificity value is 0.703, and the f1 square value is 0.5517, and this is going to be our graph. The next thing we are going to do is we're going to change the k value with 57911, and we are going to tabulate the various TP, TN, accuracy, F score, AUC, and score obtained. So for that, I'm just giving the k values and the k neighbor classifier, and we are going to fit the x train and y train. We are going to predict with kn and predict, and we are using confusion matrix, the tn, tfp, and fn value with ravel. We are using accuracy score, f1 score, predicted value, and AUC, and we are gonna result the data frame as k value, TP, TN, accuracy, F score, and AUC and score, and we are printing the result, and this is going to be our output for 3 value 3, for 5 and the value 7, for value 9, and for value 11. The next thing we are going to do is we are going to analyze and infer for which k value the classification algorithm provides better performance. For that, we are going to give the best k. The result is going to be def log accuracy dot max. For the accuracy, we are printing the max value in the accuracy one, and for AUC, again we are going to take the maximum among that. So then we are printing it for k accuracy. It is going to be 3, so the value is 9.00, TP is 42.00, TN is 90.00, accuracy is going to be 0 point something, F1 is also 0.58, AUC is going to be 0.7371, and the best among AUC is k value is 11. Then the TPE value of 11 is going to be 41.00. TN value is going to be 90. The accuracy is going to be 0.68. F1 value is going to be 0.57. AUC score is going to be 0.73. Okay, this is our output and we have completed the questions also. Thank you.